Hey guys, I'm going to work through the exponential functions review packet that I set out for you. Let's start with number 1. Write a function to model the table, then use the function to determine f of 10. So the first thing that we're going to want to do is figure out what the common ratio is. Since we don't have the y-intercept on the table, I do know it's going to happen here, but we have to figure out what this number is going to be. So to get from 8 to 32, we're multiplying by 4, and then I'm just going to double check. 32 times 4 is 128, so that's all multiplying by 4, which means that when I write my equation, f of x equals, there's going to be a number here times 4 to the x. And then just to go backwards, we're just going to divide by 4, so that's going to be 2, which means the 2 goes in there. Now, to find f of 10, we want to go ahead and plug in. We've got 2 times 4 raised to the 10th power. I'm just going to pop that into my calculator here, exactly how you see it. 2, and then 4 in parentheses raised to the 10th, and that's going to give me 2,097,152. All right. Number 2, we're going to rewrite each of these using the negative exponent rule. So when we rewrite this, I've got a 1 on top and then 5 to the positive 2 on the bottom. But because I know that I could take 5 squared, I'm not going to leave it like that. I want to rewrite it as 1 over 25. For number 2, because this whole thing is in parentheses, that means that all of it is going to go into the denominator. So 9x squared goes at the bottom, and that leaves just a 1 on the top. For C, when you have a fraction here that is being affected by a negative exponent, all you do is flip the fraction upside down. And then both of these get raised to the 3rd power. So 3 to the 3rd power is 27, and 5 to the 3rd power is 125. And that can't be reduced, so you leave it just like that. And then 10 to the negative 4 is 1 over 10 to the 4th power, which is 1 over 10,000. For 3, we are rewriting the function after a horizontal translation 2 units to the left. So when we're going to the left, we are adding 2 inside of the exponent. So that's going to look like f of x equals 2 times 4 to the x plus 2. Okay. Determine the equation of the exponential function after reflecting it about the horizontal line y equals 0. So just to visualize this for you, I'm going to graph this here, the original equation, so that you can see. I've already got 3 to the x in, so let's see. We're going to make that negative 3 to the x, and then plus 2, and I'm going to graph that. So this is what this equation looks like, and you can see that the horizontal asymptote is here at positive 2. Now we are going to reflect it over the x-axis here, which is going to take this guy and flip him upside down. So when that happens, because we're reflecting over the the x-axis, the line y equals 0, that horizontal asymptote is going to go from up here to down here. So our horizontal asymptote started at positive 2, but our new, I'm just going to write HA for horizontal asymptote, is at negative 2 after that reflection. Okay, for number 5, excuse me, the graph of f of x equals 3 to the x is shown, and it says identify the y-intercept, constant ratio, and horizontal asymptote. So our y-intercept is right here at 0, 1. Now, to identify the constant ratio, it's just the base of our function, which is 3. So ratio is 3. And then the horizontal asymptote, well, it comes right along here on the x-axis. So that is y equals 0. Now it wants us to rewrite the function after shifting it up 3 units and right 5 units. Up 3 is adding outside, and right 5 is subtracting inside. So we'll have f of x equals 3 to the x minus 5, and then plus 3 on the outside. It says, what is the equation of the horizontal asymptote after this transformation? It is y equals 3 because we took this whole graph and shifted it up 3 units. All right, next up, number 6. What is the y-intercept for the function 2 times 1/5 to the x minus 1 plus 3? Okay, again, I'm going to graph this for you just so that you can see what it looks like, and then I'll show you like the quick way to do it. So let's clear this, and I have 2, and then 1/5 in parentheses to the x minus 1 plus 3, and we'll graph. So you can tell that it's all the way up here. I did teach you that initially the 2 would be our y-intercept, but you can see that 2 is right here, and that is not on the graph. Okay, so the easy way to find the y-intercept is that you are going to take the 2, which was our initial y-intercept, but then if you are moving your thing up or down, that's also going to affect it. So 2 plus 3 gives us a y-intercept of 0, 5. Number 7, rewrite the following geometric sequences as exponential functions. So if you recall from the notes, when we rewrite this, it's f of x equals first number divided by second number, so 3 divided by 2, and then times 2 to the x. And that's it. So for the second one, f of x equals, now it's first number divided by second number. So 1/2 divided by 4 is the same as saying 1/2 times 1/4, which is going to give us 1/8 times 4 to the x. Next, we have 1 divided by 1/5. 1 divided by 1/5 is equal to 1 times 5 over 1. So that's just going to give me 5 times 1 over 5 to the x. And then last, f of x equals 12 divided by 3 times 3 to the x, which we're actually going to rewrite as f of x equals 4 times 3 to the x. Okay, number 8, describe the transformations of the exponential function g of x equals -5 to the x minus 1 plus 3. So first thing, we have a negative out in front, which means that this is reflected over the x-axis. The -1 inside of the exponent means that we are shifting it right 1 unit. And then the plus 3 at the end is up 3 units. And that's it. Okay, next we have Taylor earned the following amount each day. $1 for the first day, $4 on the second day, $16 on the third day, $64 on the fourth day. So it says write the equation of the exponential function modeled by this information. So when we do this, f of x equals, instead of a y-intercept here, we're going to start with our starting amount, which was our initial value. Our initial value was $1, so that is going to represent the first number. And then we just have to figure out how much is being multiplied. So 1 to 4, 4 to 16, we are multiplying by 4 each time to the x. And then how much will Taylor earn on the 7th day? So we're going to plug in 7 here. F of 7 equals 1 times 4 to the 7th power. When I put that into my calculator, I get 16,384. So on the 7th day, Taylor earned $16,384. So a lot of money. All right, 10. What is the horizontal asymptote of the graph f of x equals 1/2 times 2 to the x? We know that the horizontal asymptote of 2 to the x is 0, y equals 0, and multiplying that by 1/2 doesn't change, so this is just y equals 0. The only thing that changes your horizontal asymptote is moving it up or down. Okay, 11. Rewrite the expression 4 to the n minus 1 such that n is the only thing in the exponent. So what they mean is we want to have 4 to the n, and then we need to have something else. Well, I taught you that -1, that we can write this as 4 to the n times 4 to the -1, and 4 to the -1 is just 1/4. So that right there is your answer. 1/4 times 4 to the n. Okay, Thomas counts the number of cars he sees in the parking lot of the school each hour of the day. He counted the following number of cars the first hours. So we've got 6, then 12, then 18, then 24. It says describe the relationship between the number of cars in the parking lot and the number of hours he has been observing them. So we just want to describe the relationship. We started with 6 cars and then it went up to 12. So 6 to 12 is multiplying by 2. However, 12 to 18 is not multiplying by 2. So I can actually say that this is not an exponential. However, 6 plus 6 is 12, plus 6 is 18, plus 6 is 24. So this is actually a linear relationship. In which there are 6 more cars each hour. Okay. Given the function f of x equals 3 times 2 to the x, determine the y-intercept and horizontal asymptote of the function. Well, the y-intercept is 0, 3 because that comes in our a spot. And the horizontal asymptote is y equals 0 because the function has not been shifted up or down. Then is it increasing or decreasing? If you're ever not sure about these problems, you can just go to your calculator, hit the y equals button, graph that function 3 times 2 to the x, graph it and see what's happening. So that is quite obviously increasing. So this is increasing here. You have your calculator, please use it. Okay, for the following equation, identify the horizontal asymptote, the starting amount, and the rate as a percent. So horizontal asymptote, there's no plus or minus at the very end, so it's y equals 0. The starting amount is the first number that comes after the equal sign, so starting amount is 5,000. And the rate as a percent. So the rate is going to be this 0.0325. And to write that as a percent, we're just going to take this decimal point and move it to the right 2. So that gives me 3.25%. All right. In the year 2017, Rock Springs Middle School has a population of 1,033 students. The population has been steadily increasing by a rate of 0.05%. Write an equation to model the exponential growth and use it to predict what the population of RSMS will be in 2025. So the first thing that I want to do is take this 0.05% and write it as a decimal. So I'm going to take that decimal point and move it to the left by 2. So that's actually going to give me 0.0005. We are increasing, so when I write this, we're going to do our starting amount, 1033 times 1 plus 0.0005. Remember, we're adding because it's increasing. Now, to find what we're plugging in for x to get to 2025, our initial year was 2017, so I want to subtract these to determine what we're plugging in for x, and it looks like it's going to be 8. So f of 8 equals 1033. I'm going to combine these to put them in my calculator. 1.0005 to the 8th power. It looks like that's going to give me, in the 8th year, in 2025, there will be approximately 1,037 students. So only gained 4 students in 8 years, which doesn't seem like it would be accurate, but to be fair, I made up that number. So, all right, let's move on to number 16. The graph represents the exponential function that models the relationship between the temperature of a cooling beverage and the time in minutes. What was the approximate starting temperature of the beverage? We find the starting temperature right up here at the y-intercept, and it looks like it was about 160 degrees Fahrenheit. And it says, what is the temperature of the beverage after 6 minutes? 6 is here, so if I fill that up, it's very close to 110. For this problem, I would accept anything from 108 degrees to 110 degrees. Maybe even 107. We'll add the F there for Fahrenheit. And then after how many minutes will the beverage reach 80 degrees? So here is 80. And if I bring that over, it's going to be right there. And that is before, oh, that's right after 12 minutes. So I'd say that that's at about 12 and a half minutes. Okay, a biologist is observing bacteria multiplying. The biologist began with 400 bacteria in the petri dish. After 1 hour, the biologist observed that there were 424 bacteria in the dish. After another hour, there were 449 bacteria observed to be in the dish. The biologist wrote the following function to model this situation. F of t equals 400 times 1.06 t. In this case, t is going to represent our hours. Does this situation represent exponential growth or decay? So how can we tell? We are going to look at what is inside of our parentheses, our ratio, and 1.06 is greater than 1, which means that this represents growth. We can also tell from the word problem that the bacteria are increasing, so that's another way that you could tell. Then it says, what is the rate of growth or decay? So we are going to take 1.06 and subtract 1. So 0.06 is the amount that it is over. And then we're going to write that as a percent. So our rate of growth is 6%. And last, how many bacteria will be in the dish after 10 minutes? So we're going to use this equation here and plug in 10. F of 10 equals 400 times 1.06 to the 10th power. When we do that, we get that F of 10 is equal to 716 bacteria. Nope, this should have read hours after 10 hours. Sorry about that, guys. I wish I had caught that before. So sorry. Okay. Let's move on to 18. The equation f of t equals 49,500 times 0.995 to the t power models the population of Smyrna in an alternate universe where t represents the number of years since 2019. So what was the population in 2019? That was our initial value, which is 49,500. Now, I would like to mention that the reason that I added in an alternate universe is that 0.995 represents a decreasing population, and Smyrna is not decreasing. So So when we do this problem in 2025, this number is not going to be accurate to what is predicted to actually happen in 2025 in Smyrna. Just wanted to make sure you guys understood that. So 2025 minus 2019 is going to give us 6, which is what we're plugging in for x. So f of 6 equals, oh, sorry, that should have been 2. 49,500 times 0.995 to the 6th power, which is going to give me, in the year 2025, there would be approximately 48,033 people in Smyrna. Okay, last page, number 19. The number of squirrels on the school campus is increasing exponentially. After 1 month, the number of squirrels increased from 200 to 240. So I'm just going to write a quick table here. And then it says write an equation to model the exponential growth. So to do this, I'm going to take my calculator and I'm going to put 240 divided by 200, and that should tell me what my growth factor is. 240 divided by 200 gives me 1.2. So when I write my equation, that 1.2 is what I'm going to use as my ratio. So our initial value was 200 squirrels, growing by a factor of 1.2 to the x power. That's it. Okay. Determine the equation of the line that represents the horizontal asymptote of the function. We took our initial function and we shifted it down 2 units, so that's at y equals -2. Okay, the formula for exponential growth. F of x equals a times 1 plus r to the x, where a is our initial value and r is our rate as a decimal. For exponential decay, f of x equals a times 1 minus r to the x, where the initial value is a and the rate as a decimal is r. Okay, question 22 asks, what happens to the y-intercept when a function is shifted up 5 units? The y-intercept is also shifted up 5 units. Or if our function is shifted down 2 units, our y-intercept is also shifted down 2 units. All right, last problem. Eliza bought a new Mazda years ago. The value of her Mazda V in dollars T years after the purchase can be determined by the following equation. V equals 23,400 times 0.82 to the T power. Peggy purchased a Ford at the same time. The value of Peggy's Ford at the end of each year is shown in the table. So first thing we want to do is compare the purchase prices of the vehicles. So Eliza's purchase price is her starting amount, which is here, 23,400. Peggy's purchase price is the amount at year 0, which is 29,500. So Peggy's Ford cost more to purchase. You also could have written that Eliza's Mazda cost less to purchase. I believe in my initial answer key I wrote that Eliza's purchase price was cheaper. There are so many different ways that you could write that sentence. Okay, next one, it wants us to write a function to model the value of Peggy's Ford. So we know what her initial value is. We don't know what her rate is, so we can figure that out. We can put 23,600 divided by 29,500 into our calculators, and it gives us 0.8, which is going to be our decay factor. So we can write that as f of x equals 29,500 times 0.8 to the x. And then the last question, which vehicle depreciated at a greater value? Well, we have that Eliza's decay factor was 0.82 and Peggy's decay factor was 0.8, which means that Peggy's is losing money faster. And that's because her decimal is further away from 1, or that her percent is further away from 100.